Introduction to the vertical mill. This module will provide a general introduction to the vertical milling machine and explain the basic functions of milling. It will not supply specific detail on operating the machine, but it will name some of the major parts. Perhaps it is easier to understand the vertical mill and what it does if one first understands what milling is. At the risk of oversimplifying, it can be said that milling is the mechanical method of shaping or forming metal or other rigid substances by cutting. The cutting is done by these items. They are known as mills or cutters. They revolve in the machine. There is a name for the kind of cutting they do. It's called surface forming. Surface forming can be done by planing and using other single-edge tools, but milling is faster and more accurate. Take a good look at these cutters. Notice how the edges on some have an irregular or odd shape. The surface they form will be given the same shape or profile as these cutters. Cutters are made and ground in many different shapes and styles in order to form the different surface shapes that industry demands. In a milling operation, the cutting is done by having the workpiece pass beneath the revolving cutter. It is possible to do this since the workpiece is securely fastened to a movable table. To describe the milling operation in the most basic sense, one would say that the milling cutter revolves in the machine and the work is brought into contact with it in such a way that will constantly provide each cutter tooth with fresh metal to cut. In this illustration of a typical vertical milling machine, you can see some of the more common parts that you should become familiar with. The first one is known as the ram. It is the part that supports the headstock assembly and allows it to move back and forth for a working adjustment. This close view of the ram shows you the ram traverse control for the forward and backward movement of the ram. Here you see the locking nuts which secure the ram in a fixed position after the desired adjustment has been made. They are referred to as the ram locks for obvious reasons. In this head-on view of the headstock assembly, you can see the quill. It houses the spindle and makes the up and down or vertical adjustment of the cutters possible. The quill has been extended all the way down for this picture. You should be familiar with this part because you've seen it on drill presses. It's called the spindle and it's used for mounting the cutters. The spindle is the part that revolves. The drawbar at the top of the headstock is for pulling the collet up into the spindle, which then secures the cutter. A vertical mill is capable of moving the workpiece in three directions. The table moves to the left and right to give one direction of travel. Some limit has to be placed on the left and right travel, and it's the job of trip dogs or stops to do just that. The trip dog shown is set to stop the travel of the automatic table feed. In and out travel of the table is the function of the saddle. The saddle is located directly beneath the table. The knee of this vertical milling machine is the raising and lowering device of the table which puts the workpiece in contact with the milling cutters. The lever you see near the base is the knee clamp or lock. It's used to hold the table in a given position when the height adjustment has been made. The column is the backbone of the vertical mill. It also supports the knee and allows the vertical or up and down movement of the knee. Here you see a spindle brake. Actually, it's the spindle brake lever. You can move it in either direction to stop the spindle. In most machines, when the brake wears down too much to be effective, it has to be replaced because there are no adjustments. This is the power switch. It also controls the forward and reverse rotation of the spindle. Mills may also be used to drill, ream, bore, etc. This feed lever allows the quill to be fed manually. When the quill is to be fed into the workpiece under power, the automatic feed is used. The automatic feed control also engages the overload clutch. This micrometer adjusting nut is also called the micrometer stop. When the quill stop contacts the micrometer stop, it disengages the automatic feed to control the depth of feed. There are two ranges of speed on most milling machines. They usually range from 60 to 500 RPM and from 500 to 4200 RPM. The speed range is indicated by the lever marked high, neutral, low. Some mills have belts that have to be changed in order to change spindle speed. It is very important to remember that the motor must be turned off before the speed can be changed. Many mills are equipped with variable speed controls that allow the spindle speed to be changed while the motor is on. Do not change a variable speed mill while the motor is off. The motor must always be running before changing speeds. There is also optional equipment available to add to the versatility of the vertical mill. One such item is the automatic table feed. The automatic table feed is capable of moving the table in either direction and at varying rates of travel. It does not take a great amount of skill to operate a milling machine, but it does take a person with considerable aptitude for accuracy, particularly in the setting up stages of the operation. So the best advice that can be given is to check, recheck, and check your setup again before you start cutting.